So the first step here is really the last step of each of your problems. Right? This is how you check your answer. Once you get an answer, this is going to be like the end of every problem, where you get an answer that is x. The first number is x, the second number is y, so you get two answers, right? It's kind of like the same as before, but you have two answers. So that's why you write them in parentheses, because we have two of them. We got to know which one's the x and which the y. But you can check them, right? You can check them by plugging them in. Right? Make the y red. So as you're doing this, you're going to go through each one and say, well, does 3 times x equals 2? 3 times 2 plus my y, in this case is 1, right? And does it equal 7? It's the same thing as every other check. You get the same number on both sides. So you should have a step of just plugging it in, probably a step of simplifying a little bit, and then the final step of seeing is it the same number or not. So since they are the same number, then yes, this is solution. You just have to do that a few times for each of these. Okay, so you got the 3 times 3 minus 4. You can put plus -4, or you can simplify it minus 4. Right? And does that equal 7? So does 9 minus 4 equal 7? And no, 9 minus 4 equals 5. So it does not equal 7, so therefore, no. 3 comma -4 is not a solution. So it's just a check. The checking of your answer for each problem. So just go through on that separate paper I gave you and do this for each one of them. Just write out thoroughly all the work to prove if it's a solution or not. No matter which number. Well, you have to use the numbers that I give you, right?
Oh yeah, like
So x is the first number, y is the second number. Y is the second number. You do make things at once. There you go. Minus 5. So this one is a solution, yes. And you can read the directions on how to fill out the box. So with these equations, since they have two answers, x and y, the graph becomes increasingly more important. With equations and inequalities, we kind of did a lot of work, and at the very end just kind of graphed it really fast and moved on. The graph was kind of afterthought, something we did at the very end. But with graphing, with the graph you can show if it's the right answer, and with the equations, like what you're doing right now, the checking, you can show it's the right answer. But you can really check if these are the right answers graphically as well. So you wouldn't have to plug in any numbers at all, and you'd still know if they're right. So here's what I want you to do is go ahead and into Desmos for number 1, let's just use number 1, do that one together. Let's type in all the coordinates. So let's type in 2, 1, and just go down the whole, all 5 of these. 2, 1, and 3, -4, and 4, -5, and the parentheses again are, the purpose of those parentheses is to give order to our answer. So we know which one's the x answer, which one's the y answer, since we have 2 answers. So we got to put them in the right order, very important. We have to use the parentheses. So we should have 5 entries. There we go. Now the question is, 1, 2, 3, 4. Ooh. There we go. The question is, looking at these 5 dots right here, how do we know which ones are solutions just by looking at the points only? Without doing the checks where you did and you got yes or no, it's a solution, it's not a solution. how can we tell which ones are solutions just by looking at the coordinates only? Okay, so you're going to find with the graphing, you can solve it with equations and algebra, but you can also look at it graphically and see if it's an answer or not as well. So if you have all 5 points, go ahead and put in the equation as well. So the equation is 3x plus y equals 7. We got 3x plus y equals 7. Okay. And what do you notice about the answers that were yes? Yeah, they all line up on the line. So that's what it means for it to be a solution on a graph. If it's on the line, then it's a solution. So the three that I have highlighted were the first, middle, and last ones from right here. The first one, I'll make those red. Those are all the solutions, and the ones that are not solutions are not on the line. There we go. And by the way, you can change the color just by clicking on it and holding it. If you click on hold it, it'll give you an option for what color do you want. So that's how you know graphically, without plugging anything in, is it a solution or not? Right? Is it a solution or not? And you can go through and check, once you get your answer on algebra, using algebra like we did to begin with, you can look at your graph and see, well, does your graph look like an answer? Because if it's not a straight line, then it's not going to be an answer. Okay. We want to graph these. We want to graph these equations. Now you notice it doesn't have a y in here. It has this part right here, so it looks like a G with parentheses. That's actually pronounced G of X. Just so you know, so we say it properly. So when you're talking using this, say G of X equals negative 2x. G of X. And we use this different notation because look how many things are plugging in. It can get really confusing if you don't keep track of what you're plugging in and your answer. If you just keep track of your answers like we're used to doing and not what you plug in to get the answer, it's very confusing what the answer actually is because the answer is 2 parts. It's the x and the y. So if we just going to go like this and say y equals negative 2 times 1 and say, okay, y equals 1, well, what's the answer here? We know y equals 1, but what's the x? Right? Or negative 2x. We know the answer is negative 2. And the x is what? Now what is the x equals? And it gets a little confusing. So we have this separate notation that we call function notation that keeps track of both what you put into the equation and what the answer is. So it has like an input-output format. Okay. So here's how your work wants to look for all of these. We'll have G of 1 since x is 1. So we're just taking the x, we're putting in there. So this just says we're plugging in 1. That's what this notation means. We're going to plug in 1. So that's going to be negative 2 times 1. And negative 2 times 1 is negative 2. Now the reason why we like this notation is because right here we have what the x equals and what the y equals. So we know this is the coordinate 1 comma negative 2. So within our work, we have both the numbers very easily visible, and we can get the coordinate easily from there. Then we'll just go over here and plot 1 comma negative 2. And then just repeat the same process for each of them. Again, once you get the hang of it and you really get going, the work takes a matter of seconds per problem. So don't judge it by how many problems there are, because each of them is probably 5 seconds or less once you really get going. So I'm plugging in 4. So this part just means I'm plugging in 4. And the answer is going to be negative 2 times 4, which is negative 8. So I plugged in 4, that's my x. My answer is negative 8, so that's the coordinate 4 comma negative 8. Okay, so what you plug in is the x, and the answer is the y. 4, so that's the 4 to the right. We'll go 4 to the right, and then it's going to be 8 down. Right? So positive 4, 4 to the right, then 8 down. 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8. g of negative 5 will be negative 2 times negative 5. Negative 2 times negative 5 is positive 10. So this is the coordinate negative 5. Negative 5, that's 5 to the left, and positive 10, that's 10 up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And lastly, g of 3 equals negative 2 times 3. That equals 6. And we get 3 comma 6. So this is going to be 3 to the right and 6 up. So look up here. 1, 2, 3. 1, 2, 3, 4, 5, 6. Now, what is instantly wrong with this? Well, looking at the graph, how do I know it's wrong? Yeah, remember the rule here is that everything should be a straight line, right? So, if you get something like this, here's what you don't want to do. You don't want to do this. That shows you don't understand that we should have a straight line on the graph. I've seen some people do this, and you're kind of missing the big picture. It should line up in a straight line. If it doesn't, then you know something's wrong. So looking at this, I can tell that, well, these 3 are lined up in a straight line. That must mean my green one, that I made some sort of mistake, and you go back and fix it. But if this happens, you need to go back and find your mistake, but it do line up. So if I go back here, we got negative 2 times 3, it's really negative 6. So this is negative 6. So it's really negative 3, 1, 2, 3, and negative 6 right here. So clearly, it does line up in a straight line. So when it doesn't line up in a straight line, don't just connect it and say, I'm done. A non-straight line means there's a mistake. And you just take the point that's not in the straight line, you know that's the error. Okay? So all of them should be straight lines. Okay? And that's why we use this notation, because it has what we put into the equation and our answer, and it's easy to write our coordinate. Because we have 2 answers floating around. If we accidentally switch them, we put negative 8,4, all sorts of problems happen. So this notation keeps everything very organized, so we don't have any mistakes later on. Okay? So that's the end of your homework. Again, once you get going, these things take a matter of seconds, 5, 10 seconds per problem. So don't look at it and say, this is way too much, I'm not going to do it because it's going to take it forever. It'll take maybe 20 minutes if you just sit down and do it and don't stop until you're done. Oh, last thing. On here, please use a straight edge. Okay, so none of your graphs should be hand-drawn. All of them should be use some sort of straight edge. It doesn't mean necessarily a ruler, but even just folding a piece of paper, right, and drawing a straight line using a piece of paper is suffices, or a side of a phone, or anything else. So you must have a straight line going through there, not some hand-drawn kind of squiggly thing going on, right? So everything you do is a straight line. And for that purpose over here, if you don't have one, as you come in every day, there are rulers over here you can pick up if you just want to pick it up and drop it off as you come here each day. So that's why those are here. You can have a straight edge, or just use your own because you're going to have to do it on your homework as well.
Okay, I'm pretty sure